So good morning students. In the last class we had discussed about the digestion in stomach. Then after stomach the food is going to enter into the what? Into the small intestine. Here I will show you from the stomach. The food is going to enter into the small intestine. Okay, this part is known as the duodenum. And here there is in presence of one sphincter. Okay, in between the stomach and the small intestine, that is the duodenum, there is in presence of one sphincter that is known as the pyloric sphincter. This pyloric sphincter will regulate the entry of food from the stomach to the small intestine. Okay, so the next here there is in presence of one leaf-like structure. That leaf-like structure is the pancreas. Pancreas also plays a very important role in digestion. So let's see about the pancreas. Next, that is pancreas. Pancreas are the leaf-like structure, leaf-shaped gland. What are pancreas means? These are the leaf-shaped gland. Okay, and here, as I told, it's gland. It is going to secrete some enzymes or some hormones. So here, you know the difference between the exocrine and the endocrine gland. Okay, exocrine means without duct it is going to pour their secretion. Endocrine means with the through the duct it is going to pour their secretion. So here what happens? Pancreas is whether it is endocrine or exocrine means it's both. Both, that is function of both. It has a function of both as exocrine and as well as the endocrine gland. So leaf-shaped gland performing of both, performing the function of both exocrine and endocrine gland. Okay, the next here, the exocrine part consists of the acini. Here, the pancreas has two types of cells. Here, pancreas has two types of cells. One is acini and one is islet of Langerhans. What this? One is acini and the another is the islet of Langerhans. So here the exocrine part consists of the acini. Exocrine part, it consists of cells, that is the acini. Okay, so while the endocrine part produces a large number of islet of Langerhans. Endocrine part, it consists of a large number of islet of Langerhans. Okay, the next the acinar cell shows a next here you see how the pancreas are located. What will be the structure of pancreas? As I told you, in the U-shaped, C-shaped structure, that is the duodenum. Below the stomach, there is a presence of pancreas, that is the leaf-like structure. And here, inside this, there is a presence of a duct. Clearly, I will show you. This is the duodenum. Okay. Here there will be the stomach, and this is the duodenum, and here in the duodenum below the stomach there is an presence of a leaf-like structure, and this leaf-like structure we can call it as the pancreas. And inside this there is a presence of one duct, and that duct is known as the pancreatic duct. What it is known as? It is known as the pancreatic duct. So this pancreatic duct will open with a bile duct. Okay. So here there will be presence of a liver. This is the bilobed structure, which is one of the largest organ of the body. That is the liver. So from the liver, it is going to open a duct, that is from the gallbladder. This is the gallbladder. It will open through a common duct, and this common duct here, where both, that is bile duct and pancreatic duct, is going to meet. That particular duct we can call it as the hepatopancreatic duct. What it is? Hepatopancreatic duct. So this hepatopancreatic duct will open into the duodenum, where it is going to secrete the pancreatic juice as well as the bile juice together. So next we will see about the what is the composition, what is the role of pancreatic juice. Next, that is pancreatic juice. So here there is a different role of there is a different secretion from both exocrine part and the endocrine part of the pancreas. So first the exocrine pancreas, okay, which are going to secrete their secretion without ducts, that is the exocrine part of the pancreas. It is going to secrete the pancreatic juice. So here exocrine pancreas, that is the secretion is from the acini. Okay, how much pancreatic juice it is going to secrete means that is around 1200 to 1500 ml of pancreatic juice per day. Which part? Only the exocrine part. And whatever the pancreatic juice which is secreting from the exocrine part, it is colorless. That fluid is colorless. And what will the pH means? The pH is of about 8. That is alkaline. Okay. The next here, what does it contains? This pancreatic juice or the pancreatic juice from the exocrine part, what does it contains? Means it contains 1 to 2% of organic material. What does it contains? 1 to 2% of organic material. Then 1% it constitutes the inorganic substance. Okay, the organic matter, whatever the organic material, it will be secreting in the pancreatic juice. It will be the proteins, and that proteins, it is in the form of enzymes. In the form of enzymes. Okay, whatever the pancreatic juice, which constitute about 1 to 2% of organic matter or the organic material, among that, what it will be there means, whatever the organic material will be there, it will be the proteins, and that proteins are present in the form of what? Enzymes. The next term, the most important inorganic component is the sodium bicarbonate. What it is? Whatever the 1%, whatever the 1% inorganic matter or inorganic substance is present in the pancreatic juice, that is the sodium bicarbonate. What it is? That it is the sodium bicarbonate. Okay, so which makes the pancreatic, the sodium bicarbonate makes the pancreatic juice alkaline. Pancreatic juice alkaline. So, who is responsible to maintain the pH at 8 means that it is the sodium bicarbonate. Okay, the next thing, this is about the pancreatic juice. The next we will see about, in the pancreatic juice, we will see about the pancreatic enzymes. Okay, first we will see about the pancreatic enzyme. So here, next pancreatic enzymes. In pancreatic enzyme, the first enzyme is the trypsin. Pancreatic enzymes. That first one is the trypsin. Okay, here the trypsin is secreted in an inactive form. Okay, what is the inactive form of the trypsin means? That it is the trypsinogen. Here, trypsin is secreted, first of all, it is secreted in an inactive form. And what is the inactive form? Means that it is the trypsinogen. Trypsinogen. Okay, then this trypsinogen will be converted into trypsin in the presence of an enzyme, that is the enterokinase. See here, trypsinogen gets converted into trypsin in the presence of enzyme that is the enterokinase. So here the trypsinogen is an inactive form and trypsin is an active form. And this is one of the enzyme that is the enterokinase. This enzyme is secreted enterokinase are secreted from the intestinal juice. Okay, what is the mechanism? Here trypsinogen is in inactive form which is converted into the active form in the presence of an enzyme enterokinase. Okay, the next here there are some ions which are going to convert, that is hydrogen ions, which are going to convert into the active form by a reaction. In yesterday also I told you that reaction is known as the autocatalytic reaction. Okay, the next here trypsin act upon what? The trypsin act upon the proteins. See here, trypsin act upon the proteins. How they are acting on the proteins? So, see here, proteins, and that proteins are going to convert it into polypeptide and amino acid. See here, proteins in the presence of an enzyme trypsin, it is going to convert into the polypeptide and amino acid. What it is? Polypeptide and amino acids. What will be the pH which is maintained over here? The pH will be 7 to 9. Okay, then next again these proteins are going to convert it. How it is going to convert it means first protein gets converted into alkaline metaproteins. Here proteins first get converted into alkaline metaproteins. Then from this alkaline metaproteins to it gets converted into the primary proteases. Primary protease, then into the secondary protease, then into the peptones. Lastly, this peptones gets converted into the polypeptides. In this way, the proteins on the action of trypsin gets converted into the polypeptides, then into the amino acids. The next reaction, the next enzyme, that it is the chemotrypsin. So let's see about that chemotrypsin. Next that it is chemotrypsin. Second enzyme is chemotrypsin. Okay, so here chemotrypsin, this enzyme is also produced in an inactivated form. That is, what is the inactivated form means? That is chemotrypsinogen. This will get converted into the chemotrypsin. In the presence of an enzyme name is that is trypsin. At the pH that it is 7 to 9. Totally it should be alkaline. So here chymotrypsinogen will get converted into chymotrypsin in the presence of an enzyme trypsin. Okay. So here trypsin hydrolyzes peptides. Trypsin hydrolyzes peptides in the presence of some of the hydrogen ions. This trypsin is going to form the peptides linkages involving the carboxyl groups. Linkages involving the carboxyl group. Trypsin, what it will do in the presence of some hydrogen ions, it is going to break the proteins into peptide linkages, and there is also presence of some carboxyl groups. And lastly, here after this reaction, what is going to form is that is the tyrosine and phenylalanine. What will be the amino acids? That is tyrosine and phenylalanine. Okay, this is about the chymotrypsin. The next that it is the carboxypeptidase. Still 4 enzymes are there: carboxypeptidase, pancreatic lipase, then pancreatic amylase. Okay, thank you. Tomorrow I will continue.